All right, so for section 3.4, we're going to be dividing polynomials. And before we do that, we've got to go back to elementary school and do a little bit of long division review. So the first thing we need to take a look at is the fact that when you have a division problem, you have a divisor, a dividend, and a quotient. The divisor is the number on the outside that is being divided into the dividend, and then the quotient is the solution. So let's take a look at an example of how we do this. If we have 1468 divided by 12, remember that we're going to look and see, does 12 go into 1? The answer is no. So then we look at the next number. Does 12 go into 14? 12 does go into 14 once. So then you multiply 12 times 1 and then put that underneath the 14. Then you have to switch the sign on that 12 to a negative, and then you end up with a 2. Bring down the 6. How many times does 12 go into 26? It goes twice. Multiply 12 times 2, you get 24. Change it to a subtraction sign. Then you get, again, 2. Bring down the 8. How many times does 12 go into 28? It goes twice. Then 12 times 2 is 24. Change it to a subtraction sign. And then you end up with a remainder of 4. So when we do polynomial long division, we have to use the same methodology in order to be able to accomplish our goal of finding out what the quotient and remainder are. So in problem number 1, we're given 4x squared plus 23x minus 16 divided by x plus 5. So here's what we need to do. We need to look at the first term in our divisor, which is an x. And we need to figure out, what do we need to do to x to make it match the first term of the dividend, which is 4x squared? Well, to make x into 4x squared, you would have to multiply by 4x. That's what we're going to put into our quotient. So the way we're going to do it is we're going to line up, since 4x has an x to the first, we're going to line up that 4x to the first over top of the x to the first term in the dividend. Now, multiply the 4x through, or distribute the 4x through to both the x and the 5. So you end up with 4x squared plus 20x. Now, distribute a negative through to both terms. So the 4x squared plus 20x becomes negative 4x squared minus 20x. It's very important to note that this has to be done to both terms, or all of the terms that we're subtracting from the dividend. So if we've done this correctly, the first terms should cancel out. So 4x squared minus 4x squared gives us 0x squared. So we just don't even bother writing it. 23x minus 20x gives us 3x. Bring down the negative 16. So you've got 3x minus 16. So the next thing we need to do is figure out, how do we make that x in the divisor into the 3x that we have remaining here? Well, that means we would multiply the x by 3. So now we get 3x plus 15. Change both signs, and you end up with negative 3x minus 15. So again, if we've done this correctly, the first terms should cancel out. So 3x minus 3x is 0x, and you get negative 16 minus 15, which is going to give you negative 31. We can then write that remainder over top of the divisor, and so our solution is going to be 4x plus 3 with a remainder of negative 31 over x plus 5, or 4x plus 3 minus 31 over x plus 5. In problem number 2a, we're going to take a look at another rule that you need to be very aware of, and make sure that you apply this anytime that you do long division of polynomials. So the question is x squared plus 1 a factor of 3x to the fourth minus 4x cubed plus 12x squared plus 5? So when it's asking, is it a factor, basically what it's asking is, are we going to get a remainder of 0? If we get a remainder of 0, then x squared plus 1 is a factor. If we get any sort of remainder, then x squared plus 1 is not a factor. But to be able to do this, when we set our divisor up, we have to plug in any missing values that we have. So you can see we've got an x squared term, but we have no x term. So that means that when we set up the divisor, we're going to go x squared plus 0x plus 1. When you look at the dividend, which is 3x to the fourth minus 4x cubed plus 12x squared plus 5, again, we're missing an x term. So we're going to fill that in with a 0x. So the way we now have it set up is it's 3x to the fourth minus 4x cubed plus 12x squared plus 0x plus 5 divided by x squared plus 0x plus 1. Every single spot has to be accounted for when you do this. So now that we're set up and we're ready to go, we're again going to do the same process that we did on the last one. We're going to look at that first term inside the dividend, which is 3x to the fourth, and we're going to ask ourselves, how do we make x squared into 3x to the fourth? The way that we do that is to multiply x squared by 3x squared. So when you multiply x squared, 0x, and 1 by 3x squared, you're left with 3x to the fourth plus 0x cubed plus 3x squared. Now, all of those signs have to be changed. So you're going to go negative 3x to the fourth minus 0x cubed minus 3x squared. Again, if we've done this right, the first term should cancel out. And we have, so now we've got negative 4x cubed plus 9x squared left, and we're going to bring down the 0x. Then we have to figure out, how do we make x squared into negative 4x cubed? The way that we do that is to multiply x squared by negative 4x. So then distribute negative 4x all the way through the divisor, and you're going to have negative 4x cubed minus 0x squared minus 4x. Change all of the signs, so then you'll have 4x cubed plus 0x squared plus 4x. Again, we've done this correctly, so our first terms cancel, and we're left with 9x squared plus 4x, and bring down the 5. Then we ask, what do we need to do to x squared to make it into 9x squared? And that is multiply it by positive 9. Distribute that positive 9 through to all the terms in the divisor, and you're going to have 9x squared plus 0x plus 9. Change all of those signs, and you end up with negative 9x squared plus or minus 0x, that one doesn't matter, minus 9. So then our first terms cancel out, and we're left with 4x minus 4. And notice that we have nothing to drop down now, so we are done. We do have a remainder of 4x minus 4, which tells us that x squared plus 1 is not a factor of the original polynomial. In B, we're going to do the same thing. We're going to check to see if x minus 2 is a factor of x to the fifth minus 32. So with x minus 2, there's nothing that we have to do to adjust that, but x to the fifth minus 32 is missing the x to the fourth term, the x cubed term, the x squared term, and the x term. So all of those have to be filled in with zeros. So we will have x to the fifth plus 0x to the fourth plus 0x cubed plus 0x squared plus 0x minus 32. We have to do this. There's no choice. So now we've got to figure out, what do we need to do to x to make it into x to the fifth? We would multiply it by a positive x to the fourth. So go ahead and distribute that x to the fourth through. You get negative x to the, x to the fifth minus 2x to the fourth. Change both signs, so we get a negative and a positive. The first terms cancel out. We're left with 2x to the fourth. Bring down the 0x cubed. What do we do to x to make it into 2x to the fourth? We multiply 2x cubed. So 2x cubed distributed through the divisor gives us 2x to the fourth minus 4x cubed. Change the signs, so negative 2x to the fourth plus 4x cubed. The first terms cancel, bring down the 4x cubed, and then bring down the 0x squared. Once we've done that, what do we do to x to make it into 4x to the third? We multiply it by 4x squared. So 4x squared times x is 4x to the third. 4x squared times negative 2 is negative 8x squared. Change the signs. Do your subtraction or addition, and we get 8x squared. Bring down the 0x. So now, what do we do to x to make it into 8x squared? We multiply by 8x. So 8x distributed through to the x minus 2 is going to be 8x squared minus 16x. Change the signs. Do your addition or subtraction, and you're left with 16x. Bring down the negative 32. What do we do to x to make it into 16x? We multiply it by 16. So 16 distributed through to the x minus 2 is 16x minus 32. Change the signs, and you're going to see that now both terms are canceled out and we're left with 0. When both terms cancel out and we're left with 0, that means that x minus 2 is a factor of x to the 5th minus 32. In problem number 3, we're going to use something called synthetic division to divide x plus 2 into x cubed minus 14x squared plus 51x minus 54. This is much faster than long division, and you're probably going to like it a whole lot better. So the way that we do this is we look at our factor, which is x plus 2. Now remember that x plus 2 is actually x equals negative 2. So what we're going to do is we're going to create a little half box up in the top left, and we're going to plug negative 2 into that. Then we're going to take the coefficients from each of the terms in our polynomial, and we're going to arrange those in a row with the negative 2. So you can see now we've got a row of negative 2, 1, negative 14, 51, and negative 54. You're going to leave some space and draw a horizontal line or a bar, and what we're going to do is we're going to bring down our numbers below that bar, and that's going to create our new polynomial. So the first thing we're going to do is bring down that 1 beneath the bar. Now what we do is anything that's beneath that bar, we multiply it by whatever is in that half box. So negative 2 times 1 is negative 2. Go diagonally and place that underneath the negative 14. So negative 14 minus 2, that gives us negative 16. Now again, since we're beneath the bar, multiply what is beneath the bar by what's in the half box. So negative 2 times negative 16, that's 32. Move that diagonally underneath the 51. Now it's 51 plus 32 gives you 83. Multiply that 83 by what's in the half box, the negative 2. Negative 2 times 83 is negative 166. Negative 54 minus 166 is negative 200. So now what we've done is we've reached the end. Whatever the negative 200 is, or whatever is in that last position, which is negative 200 in this case, that is your remainder. The 83, which is next to it, is the constant. The negative 16 is the x term, so negative 16x, and the 1 is the x squared term. So what you can see is we've chopped off the cubic term, and we're left with just a quadratic. So the quadratic that we get out of this is x squared minus 16x plus 83 with a remainder of negative 200 over x plus 2. In problem number 4, we're going to use synthetic division to solve a word problem. So it says the polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of a shadow box. The width of the shadow box is x plus 5. What are the dimensions of the box? So our dividend here is going to be 1, 7, negative 38, and negative 240. The divisor, we're going to take that factor again, x plus 5, and say x is equal to negative 5, and so negative 5 is going to be the divisor. We've got our row set up, so now bring the 1 down, multiply by negative 5, diagonal it, 7 minus 5 is 2, multiply by negative 5, diagonal the negative 10, negative 38 minus 10 is negative 48, multiply it, negative 5 times negative 48 is 240, and negative 240 plus 240 is 0. So you can see we've got a remainder of 0, which means that we have a quadratic equation that's left over that is x squared plus 2x minus 48. Now remember, that's also in addition to the x plus 5 that we already have, which we know is a factor. So x plus 5 times x squared plus 2x minus 48. In order to be able to solve for x, or solve for all of the x's in a polynomial, what we need to do is we need to get it down to a quadratic, which we've now done. So once it's at a quadratic, you can use any of the types of factoring or the quadratic formula or whatever to be able to solve and find out what the solutions or the factors are. So x squared plus 2x minus 48 is going to factor down to x plus 8 times x minus 6. So we know that the factors are going to be x plus 5 times x plus 8 times x minus 6. The final question we're going to look at is evaluating a polynomial using p of x. Now, p of x is just going to tell you what the divisor is. So given that p of x equals x to the fifth minus 2x cubed minus x squared plus 2, what is p of 3? So all that means is 3 is our divisor, and the x to the fifth minus 2x cubed minus x squared plus 2 is our dividend. Now, remember that since we're missing some terms here, we're missing an x to the fourth term and we're missing an x term, we need to fill those in with zeros. So our row is going to look like 3 is the divisor, then 1, 0, negative 2, negative 1, 0, and 2. Bring down the 1, multiply by 3, diagonal it. 0 plus 3 is 3. Multiply by 3, diagonal it, you get 9. Negative 2 plus 9 is 7. Multiply it. 3 times 7 is 21, diagonal that. Negative 1 plus 21 is 20. Multiply the 3 times 20, you get 60. Diagonal it. 0 plus 60 is 60. 3 times 60 is 180. Diagonal that. 2 plus 180 is 182. So the solution to x to the fifth minus 2x cubed minus x squared plus 2 when we have p of 3 is x to the fourth plus 3x cubed plus 7x squared plus 20x plus 60 with a remainder of 182 over x minus 3. Just remember that when we go along that bottom row that is underneath the bar, the 182 represents the remainder, the 60 is going to be the constant, the 20 is the x term, the 7 is the x squared term, the 3 is the x cubed term, and the 1 is the x to the fourth term.